As I have discussed in another video, there are two main strategies for designing databases at a conceptual level. There are the top-down and the bottom-up strategies. In this video, we'll discuss the purpose of normalization, which is the main technique under the bottom-up strategy. Normalization is a technique for producing a set of relations with desirable properties, given the data requirements of an enterprise. This technique was developed by Dr. Edgar Frank Court in 1972. This technique is often performed as a series of tests on a relation to determine whether it satisfies or violates the requirements of a given normal form. The four most commonly used normal forms are the first, second, third, and Boyce Court normal forms. In fact, for most business applications, the relations are only required to be in the third normal form in order to be successfully implemented in a relational DBMS. In some specialized applications, the relations are required to be normalized up to the fourth normal form. The series of tests done in normalization is performed based on the concept of functional dependency among the attributes of a relation. Dependency in this case simply means the ability of the values of an attribute to determine the values in another attribute in the same relational tuple. In relational database design, the main aim of normalization is to examine all the attributes available in an enterprise or an organization and then to group them into logical relations. By obtaining the groupings of attributes that meet the characteristics of one normal form to the next higher normal form, the amount of data redundancy in the relations is systematically minimized. The file storage space required by the base relations is also reduced through this process. In theory, normalization can be used as a standalone database design technique. However, due to the sheer quantity of attributes which exist in large organizations, it is usually not practical to use normalization as a standalone technique to complete the database design. Therefore, unless we are modeling a database for a small organization with generally small number of attributes, normalization is usually used in the following two ways. One, as a supplementary technique to validate the entities from an ER model. Or two, as a supplementary technique to gather more entities and attributes from forms and documents used in the organization. To illustrate the aims of normalization, we'll look at an example of a company which manages building projects. Here shows a periodical report generated by this company. This report shows the total amount the company charges its clients in each project based on the building hours spent on the projects. The hourly building rate is dependent on the employee's position. When the data in the report is stored in a traditional file structure, for example, a spreadsheet, we can see that the information such as total charge, subtotal, and overall total are not stored since this information can be derived. This shows the data in the report is stored in a traditional file structure. By analyzing how the data are stored in this file, we can see that there exist several problems. One, project num is intended to be the primary key, but it contains nulls. Two, attributes like job class invites entry errors. As job class is a string data type, it would be more difficult to restrict the variety of values, which means the same job class entered by different end users. For example, instead of elect engineer, values like elect end and EE may be entered. 3. Table has redundant data. For example, details of a charge per hour are repeated for every occurrence of job class. Every time an employee is assigned to a project, M's name is also repeated. 4. Relations that contains redundant information may potentially suffer several updates anomaly. Types of update anomalies include insert anomaly, for example, inserting a new employee only if they are assigned to a project. Delete anomaly. It is not possible to delete the last employee assigned to a project, or delete the last employee of a particular job class. Modification anomaly. When updating a job class hourly rate, we'll need to update multiple rows. Basically, normalization aims to achieve the following goals. 1. Each relation or table represents a single subject or object. 2. No data items will be unnecessarily stored in more than one table. 3. All non-prime attributes in the table are dependent on the primary key. 4. Each table is void of insert, update, and delete anomalies. 5. All tables are in at least the third normal form. And 6. In some specialized applications, tables might need to be normalized up to the normal forms, which are higher than the third normal form. However, such requirement is less commonly encountered in a business environment.